There is a further optimization that virtual machines make, and I'm going to take a moment to mention this one, as this is one that I think is very useful to know about. And to explore this, I'm going to create a new project in Eclipse, which I'll call Exploring Strings. Now, I'm not going to be writing that much code in this project, so if you want, you don't need to copy along. You can sit back and watch this part of the video. Of course, this particular project's code will be in the closing workspace if you want to refer to it. I'm going to be creating some very simple code just to illustrate a couple of points. So I think what we'll do is create a runnable main class, and I'll call it main. And I'll need to put this in a package, of course, because I'm using Java 11 here. So let me just do that. Okay, so in this main method, what I would like to do is create a couple of strings. So let's call the first one 1, and I'm going to give it a value of hello. And we'll call the second one 2. And I think we'll also give that the same value, the word hello. Now, from what we've learned so far in this course, if I run this application, we would expect there to be 2 variables on the stack, one called 1, one called 2, pointing to 2 different objects on the heap. We've created here 2 different string objects. Now, this point only applies to strings, not to any other object type. And that is what I've just said is not quite true. It's not quite what happens. Because strings are immutable, that is, they can't be changed, Java is clever enough to know that it's safe to make both of these stack variables point to a single object on the heap, the same string object. In other words, what I should be able to do is say, let's print out, does object number 1 equal object number 2? And that first version here is going to check, do the values, are they the same? Do both objects contain the same underlying characters, the word hello? But I'm also going to print out 1 equals 2. And if that returns true, it means these are the same physical object on the heap. It's the same reference that is being pointed to by both of the variables 1 and 2. So let's run this code and see what the output looks like. And we get the word true twice. So this is because of this optimization that Java knows, even though I've created a new string object here, it's safe to reuse the previous one. There is no harm in both of these stack variables pointing to the same object on the heap because strings are immutable. Although in our code, we think of 2 different string objects having been created on the heap, actually, there's only one in reality. So what actually happens with strings is that the virtual machine puts them into a pool, and it will reuse the objects in this pool whenever it can. In general, this only happens with little strings. It won't happen with strings that are calculated from something else. For example, if I create a further string, let's do that down here, I'll call this one 3. And I'll set this equal to, I want to calculate it from something, so I'm going to create a new integer and give it a value. Let's do that first. I think we'll set it to the number 76, and then we'll call its toString method. So we'll say 3 is i.toString, and let's create string number 4, and that can just be the string 76. So we would expect strings 3 and 4 to have the same underlying value. In other words, when I do, in fact, I'm going to be a bit lazy and copy and paste from here. So when I do, does 3 equal 4, I expect that to be true. Both of these strings should be the representation of the character 76, but if I do 3 equals 4, well, unlike up here, where Java was able to reuse the existing string that was in the pool, down here, string 3 has not been placed in the pool because it's been calculated, so it won't be available for reuse. Let's just save that and check that we now get, indeed, this line produced a true. They do contain the same underlying data, but this line produced a false. They're not the same variable reference on the heap. Now, even that isn't the complete story. There is a feature within the virtual machine that we're going to talk about when we look at tuning the garbage collector in a few chapters' time. The virtual machine can actually detect these duplicated strings, and it will remove one of them and make these two variables point to the same underlying reference. We'll understand a bit more about that in a couple of chapters' time when we get to that topic. It's called string deduplication, not easy to say, but even though right now this line of code 3 equals 4 produced a false, it's possible at some point in the future that line of code could result in a true. Because of this internal optimization that the virtual machine can do, it hasn't done it yet in this instance, but it could do it in the future to say, I've got two strings here that have the same underlying value. I can remove one of them and safely point both variable references to the same single object on the heap.